you're in right now isn't real. It's pretty darn real if you ask me. Okay, so I know you guys have done scatter plots before. You've probably been seeing them since, I don't know, 4th, 5th grade.
I remember.
So we're going to do a pretty brief intro to them today, and then tomorrow we're going to talk a really, really cool real-world application of scatter plots, I think, that is, I think, pretty cool. Answering an honest question that most of you guys are going to face in your day-to-day lives going forward. But first, we're going to talk about how scatter plots work in general. So let's say that we have these two different things that we want to compare. So scatter plots are going to compare two different things. So the two things we're going to compare here is, let's say, number of cookies given to Mr. Taft compared to grade in Algebra 1. So we're going to look at students' grades compared to how many cookies they gave Mr. Taft. So what?
Yeah. Are we bribing you?
No, absolutely not. No, that's not what's going on.
It's Jared.
No, that's not what's going on. No.
Cookies are higher than grade. I'll take that in mind.
So let's say we've got one student who gave Mr. Taft 0 cookies, and that student had a grade of, let's say, 60%. Let's say we have another student who gave Mr. Taft 4 cookies, and that student had a grade of 80%. Another student gave Mr. Taft 3 cookies. That student had a grade of 70%. Another student gave Mr. Taft 4 cookies. That student had a grade of 90%.
You're keeping with the less cookies the lower of the grade.
Let's do another one. Let's say another student gave Mr. Taft 1 cookie, and that student had a 70%. Another student gave Mr. Taft a bunch of cookies, like say 10 cookies. And let's say that person had a
50%.
Say that person had a 90%. Okay. Hey, I've not asked for a single cookie from you guys. Not once did I ask for a cookie. Good Lord. I don't want your cookies. All right, so let's see. We did 1, 2, 3, 4, 5, 6. Let's do a few more. Let's do. Okay, hold on. Let's do 5 cookies, and that person had, let's say, an 85. Let's do 2 cookies, and that person has a 68. Let's do 3 cookies, and that person has 74.
This is how you teach kids, you know? Math with cookies.
4, 5, 6, 7, 8, 9. Let's do one more.
9.
I don't want to do 13. That's going to be too big. I want to cap it out at 10.
7.
Sure, we'll do 7.
I'll do 7.
And let's do 94.
We didn't do 8 on here.
It's okay. Hey, it's okay. All right. Now, when you're making a scatter plot, pretty much whatever goes in the left-hand side is known as your independent variable, which always goes on your x-axis. Whatever is on the right-hand side is known as your dependent variable that goes on your y-axis. If your table goes horizontally, whatever is on top is the independent variable, and whatever is on bottom is the dependent variable. The independent variable goes on the x-axis. The dependent variable goes on the y-axis. So independent variable, independent, means x, and that goes on the left. Now, mathematicians and scientists got together about 400 years ago, and we agreed that this was how we were going to do it. Oh, sorry. Mathematicians and scientists got together about 400 years ago, and we agreed that this is how we're going to do it. We agreed that whenever we make a table, whatever we put on the left-hand side is the independent variable, the thing that we change, and we're going to put that on the x-axis. We also agreed that whatever we put on the right-hand side is the dependent variable, dependent, and that's going to be the y. Mathematicians and scientists, we got together and we agreed this like 400 years ago. So if you're in science class and your science teacher asks you what's the independent variable and what's the dependent variable, the independent variable is always on the left-hand side and the dependent variable is always on the right-hand side. Now if it goes horizontally, the independent variable is on top and the dependent variable is on bottom. Okay? All right. Now, the reason I did this is so that I have enough room to make my scatter plot over here off to the side. So I'm freehanding this, so it's not going to be perfect. You guys are going to have to forgive me here. Now, my independent variable needs to go on the x-axis, which means it's on the bottom. I'm always going to make sure I label my axes first. So my axis here on my x-axis is going to be number of cookies, so I'm going to label that first. Number of cookies. Now my y-axis is grade in Algebra 1, so I'm going to label that too. So this is going to be grade. So one thing in math is you always want to make sure that your axes are labeled. If you're ever shown a graph that doesn't have its axes properly labeled and the scale properly shown, that's bunk. Don't believe that. A lot of times on news shows, you'll see like these weird graphs that don't have their axes shown. That's BS. People are lying to you. And it happens all the time in news shows. Okay, so our independent variable, what's the lowest independent variable we have?
0.
What's the highest?
10.
So we have to be able to go from 0 to 10. So what do we want to count by, do you think?
2.
We can count by 2s or we can count by 1s, depending on how, like, you can count either one, honestly. I'm going to count by probably 1s. You could count by 2s on your own if you wanted to. So I'm going to have 0 here. I'm going to go all the way over here. I'm going to call this 10. I'm going to cut it in half, call this 5. And then I'm just going to kind of go from there. So if that's 5 in the middle, I'm just going to go 1, 2, 3, 4. And then 6, 7, 8, 9. So that I have them nice and evenly spaced. If you wanted to count by 2s to get to 10, that's fine too. Now I have actual graph paper that you guys will have on your assignment today. There'll be actual nice neat graphs, so you won't have to make the graph yourself. That's fine. You guys with me here? Okay. Now, a note about the y-axis here. So what's the lowest grade that I have on here? What's the highest?
94.
Okay, so even though the lowest grade is 60, I don't want to have a break in my y-axis and start at 60 and then count by like 5s up to 94. I want to have my y-axis start at 0 as well. I don't want to have a break in there because whenever there's a break, it ends up distorting what the graph really looks like. So I'm going to have my y-axis start at 0, and then I'm going to count by, I don't know, how much space do I have? I have 1, 2, 3, 4, 5, 6, 7. I could probably count by 10s. 8, 9, 10. So I'm going to count by 10s here. You could count by 20s or something else if you wanted to on your own graph. I'm going to count by 10s. So we'll do 10, 20, 30, 40. If you want to count by 20s, that's fine. 50, 60, 70, 80, 90, and then up here I've got 100. Move this down a little bit so you can see it better. Okay. All right. So now I just need to fill in the points. So my first point is 0, 60. So 0 on x, 60 on y. So 0, 60 goes right there. My next point is 480. So I'm going to go over to 4 and up to 80. My next point is 370, so 370, which is right there. Then I've got 490, which is right there. Sure. And then so let me just go through that again. I got 060, I got 480, I got 370, Then I've got 170. And I got 1090. 1090. Right there. 585. Right there. 268. All right. Do you guys generally see the pattern that's formed by this?
The more the cookies, the higher the grade.
Generally, right? Is that always the case?
No.
No, because there's this dude right here who gave me 2 cookies who didn't get as high a grade as they should have, and there's this person here who gave me 3 cookies who got a higher grade, who got as high a grade as the person who gave me 10 cookies. So it's possibly it depends on the quality of the cookies. That's a good observation.
Are these Oreos or not?
Maybe. I don't like
Fake
Oreos.
What?
They're fake Oreos.
I don't like Oreos.
Maybe they're vanilla Oreos.
I like vanilla Oreos more than regular Oreos. Okay.
I like vanilla.
So anyway, so what's happening here is this is not a perfect relationship. But what this is called a linear correlation. So I'm going to write that word down. I want you guys to know it. This is called a linear. So that has the word line in it, meaning it looks like a line, linear. And then it's correlation. Bless you. Correlation. Linear correlation.
Everywhere a person tries to like every time.
I didn't understand that either.
What is that supposed to mean? Correlation?
So let's break the word down then. Co meaning together, and related, correlation. They're related. They're related together. They're correlated. And they're correlated in a linear or line fashion. So they are related together in a fashion that looks like a line. Okay? So linear correlation means that the way that they relate to one another is in a way that looks like a line. There's other kinds of correlations that we'll talk about later in the year. There's quadratic correlation, which sounds scary.
It's scary.
I know.
Dangerous.
Big words.
Like a rabid dog.
All right. So here's the next part that I'm going to ask you guys to have to do here. I know, there's more. So here's the next part that you're going to have to do. You're going to have to take a super scientific tool known as a straight edge. And I have some of these, but you can also borrow 2 of your, or one of your own or whatever. You just need a piece of something that's a straight edge. And you're going to pick 2 of these points that you think best represent the data. So, like for example, if you think these 2 points here best represent the line that's showing off this relationship between these points. So like if you think the line between these points is this way, you see what I'm saying? Like, do you think that the line representing all of these points has that kind of slope?
No.
So does anybody think that it should be these 2 points here?
No.
Okay.
It should be the sixth.
What about it? Should it be these 2 here?
Yeah.
No. Wait, no. Which one?
So should it be this one and this one?
No.
Okay, that's kind of shallow, right?
Yeah.
So what you want to do,
The lowest to the highest.
okay, you could do lowest to highest. That won't always be good though. You want to pick it so that you have, and this, you won't be perfect, okay? I'm going to have to check each of yours individually. You want to have it so that you have roughly half the points above and half the points below. So I'm going to pick, let's say, those. So I'm going to pick this one here and this one here. Because if I do those two, I have a few points above and I have a few points below. Do you guys see that? Kind of, sort of? Now, those 2 points are 0, 60. And then this other point right here was 5, 85. Now, I want to find the line that's going to connect those two. Well, hot diggity, we've been finding equations of lines for weeks now. Right?
Yeah.
We can super find the equation of a line. So first thing I'm going to do is I'm going to find the slope between these 2 points. So I'm going to do 85 minus 60. So 85 minus 60 over 5 minus 0. 85 minus 60 is 25. 5 minus 0 is 5. 25 over 5 is 5. So that's the slope. And then I'm going to pick one of these 2 points. So which of the 2 points do we want to use? Juju, which one do you want to use? Cool. So I'm going to do, this is my slope. So my final answer is going to look like y equals blobbity bloop x plus bloop. I'm going to put 5 in there as my placeholder already. So then I got to do y equals mx plus b. And then if I'm using 0, 60, this is 60 equals 5 times 0 plus b. 5 times 0 is 0 plus b. Then if I subtract 60 from both sides, I get that b equals 60. So then my equation is y equals 5x plus 60. Kind of, sort of? And there we go. That's my equation representing this line. Now what I can do with that is if I had another student come in who gave me like 75 cookies, and I wanted to guess what that person's grade would be.
You would have the highest grade.
500. Would have 100%.
Yeah, I could put 75 in for x. I could do 5 times 75 plus 60 and find out what their grade should be.
That kid would have like
A huge grade, so much extra credit, right?
perfect.
Okay. So this is what scatter plots can do, and this is a real-world application, not a kind of funny real-world application. Tomorrow we'll look at a real application of using lines. Tomorrow we'll look at a less funny application of using lines. Let's take a look at our assignment today, though. Well, tomorrow's kind of is the
I know it doesn't.
What's it about?
Look, so it's about whether or not women get paid less than men.
That's going to be a big argument.
No, it doesn't.
I generally don't.
Very sad.
Just make more Oreos for you guys.
Okay.
You're not American.
Yeah.
What?
Today's the 29th.
Yes, I haven't changed the date yet.
Yes,
So I haven't changed the date yet. Today's the 29th. I haven't changed the date yet. Today's the 29th. Yeah. Okay. So I also, this doesn't have any fun things on it. So if you want to add fun things to your X and Y axes, you feel free to.
they're lying to us. Number of dinosaur chicken nuggets.
Sure. Number of dinosaurs to number of people or something. Sure. Sure. Okay. On this, the axes are already labeled too, so are not labeled, they're already scaled. So all you have to do is essentially just put the points on there. Right, and then, so what you need to do, oh yeah, state if there appears to be positive or negative. So I didn't talk about this. So if when you've got your graph, if it's going up from left to right, this means it's positive. I forgot to tell you guys about this. And if it's going down from left to right, that means it's negative. So I forgot about that part. So if it's going up from left to right, so like pretend like you're riding your bike. if you're going from left to right and like you're riding your bike and you would need to put in extra effort, so you have to put in positive effort riding your bike from left to right, that means it's positive. If you'd have to put in less effort, if you'd have to put in negative effort from left to right, then it's negative correlation. Well, yeah, if you're riding your bike, you take your feet off the pedal, right?
Where are there 3 tables on all?
Would you, oh, these are just the points.
Oh.
So like these are, you'd have to put all those points in. Yeah, you just graph those points.
That's too much.
Well, you can always refuse to.
Yeah.
Well, I mean, you've refused to do some of your assignments before. So you're just graphing these points. So like number 1, 0.6490. So here's 0.5. You're going to have to, you know, you won't be perfect. I'm not going to be like, that's 0.7, not 0.6. So 0.6490 is going to be about right. 0.7440 is about right. 1.7380 is about right. You make these stand up. And 2.9360 is about right. Wait a minute. Yeah. 3.7, 3.7, 300. About right there. And then 5.3. Wait. 3.7, 330. And then 5.3270. Bless you. 5.3270. And 6 to 10. 7.4190. 7.8. 110. Okay. No, probably not. So, is this a positive or a negative correlation? Negative. Because if you're going from left to right, and you were riding your bike down this or on this hill, you would need to put in less effort. So this would have a negative correlation. So you would say negative for correlation. Now you need to pick 2 points that you think best represent the thingy thing, the relationship.
Vocabulary picking.
I know, I'm not very good with nouns. So two points that best represent the relationship.
Like he's an algebra teacher, not an English teacher.
You think which ones? Okay, so you think it should be this one, which is 0.7440. So Christina thinks 0.7 comma 440. And what's the other one? The last one? Christina thinks the 7.8 comma 110. Okay, so to find the slope between these 2 points, I'm going to use, I don't know, let's say the Mr. Taft method. So I'm going to stack these two, 7.8, 110. I'm using this point here, 0.7440, and 7.8, 110. You could use 2 completely different points and you'd get a slightly different answer, and that's okay. So I'm going to use the Mr. Taft method here. You could use the formula and that would be okay. So 410 or 440 minus 110 is 330. 0.7 minus 7.8 is negative 7.1. And then 330 over negative 7.1. It's a decimal. It's a good thing I'm letting you guys use your calculators. So in this case, now when you're doing, here's another thing about quote unquote real world math, is real world math is never anywhere near as nice as the math that I've given you guys on your assignments. So real world math is always going to have decimals and stuff. Well, not always, is often going to have decimals involved. So I'm going to do this 330 divided by negative 7.1, and I'm going to round it to 2. What? Depends on the calculator.
The minus sign.
Depends on the calculator. So I'm going to round this to 2 decimal places. So I'm going to round this to,
Negative 40.
so negative 46.48. And that's what I'm going to leave as my slope. So from here on out, I'm going to round my decimals to 2 decimal places. Okay? That's the thing about quote-unquote real-world math, is it's way messier than all of this quote-unquote fake world math that I've been giving you guys. Real-world math is sticky and messy and not nice. From here, I'm going to find the b. So that's my m. So my answer is y equals blobbity bloop x plus bloop. I'm going to put negative 46.48 in for m. Trying to find b. Y equals mx plus b. So I'm going to use 7.8, or yeah, 7.8, 110. So 110 equals negative 46.48 times 7.8 plus b. So I'm going to do negative 46.48 times 7.8 is that whole big thing. And I'm going to add that 10 plus, no, probably not, 362.54, and I get 472.54. 472.54. Okay. And so then this is the equation of the line. Well, that's just the b. The full equation of the line is y equals negative 46.48x plus 472.54. Yeah, real world math. Like you guys have asked me before, this is how real world math is.
I don't like real world math.
It's messy and sticky.
Nobody was talking to
Hey,
you.
Tyler, shush. Nathan, shush.
I'm fine with it.
Nathan, shush. When I was watching a documentary the other day about the Concorde,